Good morning, mathematicians. It's week 20, and we are looking at Monday. We are going to start off with a question asking us to find the number that each expression equals. Notice all of these are a fraction times a whole number. So number one is asking us what 3/5 of 90 equals. Number two is 5/5 of 90. Number three is 7/5 of 90. And number four here is 10/5 of 90. Well, the first thing I want you to realize here is all of these are asking you to figure out some portion of fifths of 90. So my very first strategy, my very first thing I'm going to do is I'm going to figure out what 90 divided by 5 is, because this is going to tell me what 1/5 of 90 equals. And then, for example, for number one, I can take 3 of those, right? And so on for all of these. So the first thing that I think about when I have 90 is I know one way that I can do this pretty easily is to break this into a 40 and a 50, right? Can I first do 50 divided by 5? Because that I can quickly see is 10. Then I'm going to add to that what 40 divided by 5 is, which 40 divided by 5 is 8. So right away, I see that 1/5 of 90 is 18. And that is very helpful for all of these questions, right? So the first thing that I think about when I have number one is if 1/5 of 90 is 18, I really need to know what 3 times 18 equals, and that will be my answer for number one. Well, 3 times 18 is 54. Now, number two is really asking me what 5/5 of 90 is. Well, isn't 5/5 1? And if I multiply anything by 1, I get that thing that's being multiplied by 1. So in this case, it's really 1 times 90, which is 90, right? Now that makes me think about this question down here and how those are related. If 5/5 of 90 is 90, then double that would be 10/5 of 90, right? So I know right away that I can take this 90 and I can double it to get 180 for that question number four. So the last thing that I am looking for here is what is 7/5 of 90? Well, if I know that 1/5 of 90 is 18, 18 times 7 is really what I have to answer for number three. And 18 times 7 gives me 126. So that is how I figure all of that work from 1 through 4 on this very first concept. Now let's go to number 2, where it says to use partial quotients to find the value of 726 being divided by 6, right? Well, I went ahead and wrote it over here to give me a little bit more space to work, and I see a very good first take. The first thing I'm going to do is 100 groups of 6, because 100 times 6 is 600. That's going to give me just 126 to treat as my next dividend, right? Well, I know that 6 times 2 is 12. So 6 times 20 would be 120, right? A 12 with a 0. So now I have 6 remaining. Well, 6 goes into 6 one time. So I'm going to have one more group of 6, and now there's no remainder. Now, when I add this all together, I have 121. So notice how I have used partial quotients in order to find the value of this question. Now we're going to take a look down below at and explain why. This says explain why 655 divided by 5 equals. And notice I went ahead and wrote it out down below for us. The first thing I want us to notice, because we know that these are true, it's just asking us to say why we know they're true, right? How we know they're true. Well, we're starting with 655 as our dividend, and it's being divided by 5, our dividend. So look at what they did. They took that 655 and they broke it into a group of 500. Then they had a group of 150. So 500 plus 150 is 650. So far, they've used up 650 of this, which means that they had 5 remaining. So 500 plus 150 plus 5 is that 655, the dividend that they had. So the next thing that they had to actually do is figure out the division. Well, what is 500 being divided by 5? Well, that would be 100. So this particular expression, 500 divided by 5 is 100, right? Now, the next expression here, what is 150 divided by 5? Well, that would be 30, right? This expression equals 30. My last expression that I need to add is 5 divided by 5, which is another group of 1. So now I know that my answer here, my quotient, will be 131. Now, we also need to explain in words why this worked, but part of me breaking it down and thinking about why it worked was actually working it out to get my answer of 131. So now when we are asked to explain this, I could say that we are breaking up the dividend into its separate units and dividing those first. Or I'm just going to write dividing. Yeah, I'll write dividing those first, right? The last thing we do then, of course, is to join those back together to get our actual answer, our actual quotient, right? That is why this works, which now we have our explanation as well as our. Let's go to our next problem where it says, solve the following using the partial product and area model method. So what we are doing here with this area model is in these 3 rectangles, we see our dividend. We see 448, right? Well, that 448 was broken into 4 groups. So here, how many do we have? Well, 4 goes into 400 100 times. 4 goes into 40 10 times. And 4 goes into 8 2 times, right? So in this area method, we would join those together. We would have 112, and that would be our answer. So we've answered it here in red with the area model method, right? Now down below, we're going to think about exactly what that looked like in our problem. So really we had 400 and it was divided by 4, which gave us an answer of 100. Now here we had 40 being divided by 4, and that gave us a partial quotient of 100. Now we had 8 being divided by 4, and that gave us a partial quotient of 12. Well, 100 plus 10 plus 2 is 112. Now, our last question for today. Find the product for each. Explain your reasoning. Well, if I have 60 times 1, I have 60. Then if I add a 0, I have 600. So my answer here is 600. And when I'm asked to explain my reasoning, I could just say, I added a 0 to 60, right? Because it wasn't just 1 times 60, it was 10 times 60. Let's use similar reasoning here. If we have 60 times 1, that of course would be 60. But now we have 2 extra zeros outside the basic frac, so our answer is 6,000. What would our reasoning be? Well, it would be that we added 2. Oops, TWO. Let me go over that. Let's use the right kind of 2. Okay, we added 2 zeros to 60. There we go. Now, this last one is kind of fun because can't I use the answer to B to help me with C? If I know that 100 times 60 is 6,000, I've used up 100 of this, but I still have to do 20 times 60, right? Well, 2 times 6 is 12. And then there are 2 zeros outside that basic fact. I really just have to add those together, don't I? So my answer to this question is 7,200, right? And I'm actually just going to leave this as my explanation of my reasoning because really that's what I did. I did here, this was like 60 times 100, and then here I had 60 times 20, right? So that is further explanation of what we did for that part C of our final question for today.